In this video, we will be simplifying square roots to get some practice with the concept. We first want to remember that given the square root of a number a times the square root of a different number b, the product will be a square root of a times b. This is supposing that a and b are greater than 0, otherwise we would end up with a negative radicand, or a number inside the square root, meaning that we would deal with imaginary numbers. So our first example is simply equal to a times b, right? 3 times 3 is 9, meaning that it is 3. The second example, do the same thing. We are left with this constant outside times square root of 10, because 5 times 2 is 10, and we know that square root of 10 cannot be simplified. Likewise, in this example, we have the constant 6, and then we have the square root of 49, as 7 times 7 is 49, meaning that we're left with 7 times 6, or 6 times 7, equals 42. We have the square root of 3 times the square root of 2. Using our properties, we know that this is simply the square root of 6, as 3 times 2 equals 6. And here, we know that 4 is a perfect square, and that the square root of 4 would simply be 2. So 3 times 2 times the square root of 3, which cannot be simplified, meaning that 3 times 2 is 6, and square root of 3 is square root of 3. So our answer is 6 times the square root of 3. 2 times the square root of 3 times 2 times the square root of 6. We multiply the constants in the outside, so we're left with 4, and then we multiply the radicand, meaning that we're left with 4 square root 18. Except that square root of 18 can still be simplified, in that it is equal to 4, so 4 times the square root of 9, times square root of 2. We simply broke down 18 into 2 square roots. 9 is a perfect square, meaning that we're left with 4 times 3 times the square root of 2, which is a non-perfect square. So our answer is 12 times the square root of 2. The square root of 6 times the square root of 2 is simply equal to the square root of 12, as 6 times 2 is 12. So we're left with the square root of 2 times the square root of 2 times the square root of 3. Why is this? We know that 2 times 2 is 4, 4 times 3 is 12. So we just broke down the square root of 12 into 3 square roots. And we know that these two simply make 2, and that square root of 3 cannot be simplified. So our answer is 2 times the square root of 3. In this example, 3 times the square root of 8, we can rewrite this as 3 times the square root of 2 times 2 times 2. And we know that this is equal to 3 times 2 times the square root of 2. And then we would have the rest of the equation, 4 times the square root of 10. So we can simplify this. So let's simplify 3 times 2. We know that this is simply 6. So we're left with 6 times the square root of 2 times 4 times the square root of 10. Once again, we multiply the constants in the outside, and then we multiply the radicand. So 24 times the square root of 20. The square root of 20 is simply, so let's rewrite the square root of 20, is simply 4 times 5. And we know that 4 is a perfect square, so we're left with 24 times 2 times the square root of 5. And this is equal to 24 times 2 is 48. Square root of 5 cannot be simplified, so our answer is 48 times the square root of 5. Now we're going to simplify square roots with negative radicands. We want to recall that the square root of negative 1 is equal to our imaginary unit, I, and so given the square root of negative a, we can simplify this as I times the square root of a. This is because the square root of negative a is simply the square root of negative 1 times the number a, and we had previously said that the square root of negative 1 is I, so we're left with I times the square root of a. Using this information, we know that square root of negative 5 is simply I times the square root of 5. And so I times the square root of 5 times the square root of 3 is simply I square root 15, because square root 15 cannot be simplified. Using the same information, we can break this down into I times the square root of 2, square root of 2, times I times the square root of 6. And so we're left with I squared times the square root of 12. I squared because we multiply I and I, 12 because we multiply 2 and 6. And so we're left with negative 1, I squared is negative 1, times the square root of 3 times 4, because 12 is 3 times 4. And we can extract this perfect square, and we're left with negative 4 times the square root of 3, as the square root of 3 cannot be simplified. Finally, we have the square root of negative 20 times the square root of negative 5. We can rewrite the square root of negative 20 as I times the square root of 20, and we can rewrite the square root of negative 5 as I times the square root of 5. I times the square root of 5. Now, it is true that we can simplify square root of 20, but if we observe here, we know that I squared and square root of 100 would result. And we know that square root of 100 is simply 10, and we know that I squared is negative 1, so we're left with negative 1 times 10, meaning that our answer is negative 10. We are given the square root of negative 27 times the square root of negative 3. Before solving this problem, it is important to note that the square root of negative a times the square root of negative b does not imply that these two negatives cancel out. What do I mean by this? One might say that we have negative 27 times negative 3, so the square root must equal 9. To confirm our answer, let's use our previous method. So we know that the square root of negative 27 is simply I times the square root of 27, and that the square root of negative 3 is simply I times the square root of 3. We multiply I and I, so we're left with I squared, and now, since these two numbers are positive, right, we can multiply them, and we're left with I times the square root of 81. I squared is simply negative 1, square root of 81 is simply 9, so our answer is negative 9. And using this method, we can confirm that the square root of negative 27 times the square root of negative 3 does not equal 9. Now that we know this rule holds true, we want to see what happens when we multiply negative 2 times the square root of negative 1 and the square root of negative 24. Before doing this problem, it is important to note that the negative square root of a, which simply means negative 1 times the square root of a, does not equal the square root of negative a, because we know that this is simply negative 1 times whatever the square root of a might be in its simplest form, and that this square root of negative a is simply I times the square root of a. So in this example, we know that the square root of negative 24, so the square root of negative 24 does not equal negative square root 24. Rather, it equals I times the square root of 24, and we will see this. So first, we simplify this term, which is simply negative 2i, square root of negative 1 is I, and the square root of negative 24 is simply I times the square root of 24. We know that negative 2i squared, so we multiply I and I, times the square root of 24, which is simply 4 times 6. 4 times 6 is 24, and using this information, we can simplify I squared, which is negative 1. So negative 2 times negative 1, and square root of 4 times 6, we have a perfect square, square root of 4. So we're left with times 2, and then square root of 6 cannot be simplified as it is, meaning that we're left with 4 times the square root of 6.